Alright guys, let's do this question. What is this question? Longest common subsequence, right? Okay. How can we do this? So this is given two strings, text 1 and text 2, and then we have to return the length of their longest common subsequence, right? If there is no common subsequence, return 0. Longest common subsequence, okay. What is a subsequence? A subsequence of a string is a new string generated from the original string with some characters. A subsequence of a string is a new string, okay, generated from the original string with some characters, can be null, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of A, B, C, D, E, like A and C and E, okay. A common subsequence of two strings is a subsequence that common to both strings, okay. So we have to find the longest one. Okay, let's say we have this example here. So we have to find the longest common subsequence, right? So we have to okay. I think it's gone, but let me reopen it. Okay. So edit, not view, best fit. Okay. Alright guys, okay. So this is the example. We can like this. Let's say we have this A, B, C, D, E, and we have this A, C, E, right? Let's say we are here, right? This and this. If they both are okay, same, so we can move ahead. We have to find the longest common, right? Okay, then this is okay. This, then we are here. This is not same, right? So what we can do? We can stay here for this, and we can move ahead with this, like that. Okay. Okay, I think I got this trick now. Let's code this, guys. For coding this, are we streaming or not? Yeah, I think yes. Yeah. So the text 2 and text 1, we have some. We have to take this. Text 1. So string text 2 here, and we have some index, right? Okay. So in case of string, how we access string? Char 8, right? Char 8 we can string like that. Okay, let me also confirm this, like how can we access index in what? Index in string C++. What are the voices? Okay, these are the operators. We have a string we can access like this. Okay, character and This is one way using the at. Okay. I think this is the best way, I think, here. Right? Can we pass a string by reference? Okay, yes, you can, like that. Okay, so we are going good, right? So there is no problem, I think. Let's do this later. No problem doing this, so let's do the index if I is greater than or equal to text1 dot size, right? Or I is greater than equal to text2 dot size. If it equals any of the bigger, then we will return 0 in that case, right? Okay. Else what we can do? Okay. If text1 not I equal to text to I, then what we do? What we will return 1 plus f of text1 text2 comma I plus 1, right? We will move forward. If it is not equal, then else what we do? We return the max of f. Okay. Okay, so we have to take the two I indexes, I think, because yes, because there are two operators. Okay, and I and j we have to take, right? And I and j. Okay, and I is text1 and j is for this. Okay, text2. And in this case, I will also move forward and j will also move forward. Okay. Then, alright, then in this case, max of this and this, that is not so. Okay. text1 text2, right? I plus plus, or you can say plus plus I and j, like that only. Okay, comma f of text1 comma text2 comma I comma plus plus j, right? Can it work? I think it should work, because okay, not like that, not plus plus I plus 1 like this, and this is j plus 1. Okay, this is the best way. And for this, what we do? Return f of text1 comma text2 comma 0 comma 0. Okay, can this pass? Comparison error provide. I have declared here. Okay. Alright. So this is a little bit whatever. not certainly. I plus 1 comma j plus 1. So this is now AC. Okay. Can we run this? Okay, this case is not one. Okay, alright. Why it's not running this? Why this view is like this now? Huh? Okay, now it's okay, so why it's not Section text to 0 I j. Okay. I is not like this. This is should be like this j here. Alright. Now I think it should work. Yeah. It will give us TLE, so we will use DP in that case. Right, guys? We will use memorization. TLE is the giving. How we can use the memorization in this case? Let's see, because two indexes are there, and let me A, B, C, D, E and A, C, E, right? So this thing is like we have A, B, C, D, E. We have A, C, E. If let's say go like this, right? If these both are, so this is the tabulation. So tabulation is not we are doing what? Next we are doing the memorization. Memorization what? We will take the 2D DP if like this. Yeah. Okay, now I understand. Because one function will go deep, right? So it will have some answers before function 2 goes deep. So I and J are there. Okay, I understand. This is very simple to type vector right. DP. Let's say time is equal to text one vectors size equal to text 2 vector size. Right, guys? So alright, so y and g are there, m comma vector of int and comma 1 here, right, and we pass this dp from here, and we take this dp from here. Here we will pass that also, right? Like this, pass it by reference. Right? Okay. If dp of I comma j not is equal to -1, return p of I comma j, right? And for this dp of I comma j is equal to this, right? And this is also dp of I comma j is equal to this. Then we have, oh no, just one thing is left because my argument case is okay, dp here and we pass the dp also here and here also, right? I think it should work now. Yeah, and now it will not give TLE to us because accepted. Let's because runtime is very slow, we can use this at tabulation also. Let's perform this tabulation here. Okay, right. This tabulation goes like this. Okay, let's draw a line first, right? Like this, correct. So A and A is matching 1, right? 1 plus V forward, A and B is matching now. So where it will go? Okay. Okay. And B is not matching, so it will go with I minus 1 comma j, okay, and I comma j minus 1, whatever is the max. So I minus 1 is this, there is no upper line, so we will initialize that is with 0. Alright guys, and j minus 1 we also initialize with 0. Empty. Alright, like this, 0 and 0. Then C, okay, I minus 1 comma j, it's 1 here. Okay, V 1, I minus 1 here. C plus 1 plus, okay, I minus 1 comma j minus 1. Why it's why this is so? So this will give us 1, right? This is all 1. So this will become 2 like this. Alright, now I understand, and let me go and put this. When we have this to vector dp, we have to take this one more. Okay. That's 1, and we have to initialize with 0 all around, all that. And we have to try 4 and try into 1, comma, okay, I like an m, into m, I plus plus, because okay, for j equal to 1 here, to n, j plus plus. Alright, what we will do, Okay, so let's take this from here. If this condition is true, right? Okay. If text of I is equal to text of j, what we do? We do dp of I is j. We like return this dp, and what we do is 1 plus. Okay, we take this one here. What is both the dp of I minus 1 comma j minus 1, right? The text I minus 1 we have to take like this, okay, because we are taking with this, okay, so like that, okay, right. If like this is not true, else dp of I comma j is equal to max of dp of I minus 1 comma j comma dp of I comma j minus 1. Alright. And what we do, we return dp of I comma m comma n. Right, guys? I think we are good here. What? Where? Alright, then mismatching forward. Alright. Right. Is right now. It's going good, guys. I think it's going good. Now we beat 81%. I think this is one of the best solution you can find in calculation method. Let's go to the next question. Let's mark this question as done. Where was it? Dynamic dp subsequence. Okay, this is okay. After dependent strings, okay. So we have done this longest common subsequence already, and this is print longest common subsequence. So we have to print it also. So is it a hard question? Why it is a hard question, guys? So it's easy, medium, lead code. What is it? We already done this, okay. Let's go here. Naukri.com code 360, right? So how can we print the longest one? We can print, right? Don't worry. I have an idea. I have read this. So this is also length, and let's do one thing. First comments is given. Okay, why is it hard or what? Am I logged in here? Login. So I am trying to log in, bro. How to log in? I have this email. I will be back in a minute. I am going to drink some water. Is this a hard problem or what? What was this? Okay, let's see. Given two string stable, final length of the longest common subsequence. The subsequence that is a common to the string. Pick your answer. What? A, B, 2, what? So I don't have the final length. I have already done that. What are you doing? That's what I'm saying. But output is here giving 2 and 3. It's not so it's saying something else and it's doing something else. And, all are length based, which I already done. So let's do this. All are length based. I have done this. All right. That's longest common substring. We can do on the lower term GFG also right here. I'll be back in a minute. Alright guys, let's do this thing also. Longest common substring. Substring you all know. We can't skip any character. So we have to find this. Okay, we have this. Let's take this example. You see here. Okay. This is the example here, guys. And we have to find the longest common substring. So this is A, B, C, D, G, H. We have A, C, D, G, H, R. If we are here and we are here, what we can do? We can go here from here. 1 plus. You will find if it is the same, go out again. If they are different, if they are different, right? So what? So we have to again move forward. Because they break the consistency, right? Yeah. So it's like if we start from here, then we get the longest common, or if we start from this, then we get longest. If we start from this, and then we get longest common. So. No, wait. So I'm understanding some things, but some things are going out of my head also. Because let's say A and A are same, right? We go for B, C, D, G, H, comma, C, D, G, H, R, right? We go for this. And 1 plus is going. 1 plus from this, right? This. Then we have this B and C here. They are different, right? They are different in this case. So if we are starting from here, and this is giving only of. So do we have to return 0 from here? Return 0, yeah. Else, if they are also same, right? Then we go for 1 plus again. Then again, let's say this was also B, right? Then 1 plus C, D, G, H, comma, D, G, H, R. And this is 0 return, this will return as 2, right? This was the one case. If they are both same. But if, let's say, this was not same altogether, B and C. This was C and this was B. Okay, B, C, like this. Okay, C. A and C is not same, right? So are we going? One plus okay. So are we doing this like? I'm a little confused, guys, because let me see. So this was like that, and this was and A is same, then they are different now. So when it is same, in this case it should return 0, right? It should only return 1. Okay, then we increase it, or what we do, I will know. It is not same. So if it is not same here, B is here, C A is here, okay, and one is B and A is here. Okay, we can do one thing. If it is equal, right, A and A, so what we return? Return max of 1 plus we are going forward with this, right? Like B C D G H, comma C D G H R, and comma max of what we do? We are getting this A only this here, B C D G H, comma C D G H R, like this, right? And right, comma like this, comma B C D G H, comma A C D G H R, like this. Whatever gives the max, we will return that if it is equal, right? Else return 0. Will this work? I think it should work. Can you try on this? Yeah. Let's take some small example like A, B, C, D and C, B, C, E, like this, right? A, B, C, A, B, C. Okay, A and C is not different, so it will return 0 only. Oh, it's a very wrong approach, guys. Because they are not different, then works of this and this. Okay, guys, now I am getting it, because let's say if it is not wrong, then we will go for this and this, or like A, B, C, D, comma B, C, E, this is 1, and B, C, D, comma C, B, C, E. We will go for max of this, right? And if they were equal, then 1 plus we move forward, maybe move forward. Correct. how will we solve this? I think I am missing some point here. I think I am missing some point. Just try to code this, then find what the meaning of coding is if you are not understanding this. A, B, C, D, C, B, C, E. Max of A, B, C, D and C, B, C, E, comma A, B, C, D, B, C, E, comma B, C, D, comma C, B, C, E. Like this. Let me try to code it and see what will work on. So we have this string about. So we will have a function here, right? We have a function here, which we have here. We will take a string S1, string S2, right? And integer I, integer j here, it will also take. Okay. If I is greater than equal to S1 dot size or j is greater than equal to size, right? In this case we have to return 0, and after that what we can do is, if S1 of I is equal to S2 of j, right, we return 1 plus of fs1 comma 2 comma I plus 1 I plus 1 comma j plus 1, right? This is not, but if it is not the case, so what we do, else return f of s1 comma s2 comma I plus 1 comma j, right, comma f of s2 comma s1 comma s2 comma j plus 1, right? We have to return the max out of it, right? So here max of this, okay. This is directly formula for subsequence, bro. This is exact. Right. No. This is subsequence formula. How can we make this subsequent? So we get something. So it will tell like how we are coming from finding the equal. So can we do this like, okay? Can we do like this? We have this like if I is greater than 0 and j is greater than 0 and s of I minus 1 equal to S1 of S1 equal to S2 of j minus 1, right? And sub I is not equal to S1 of I is not equal to j. Then in this case we will return 0. What do you say? Return f of s1, s2, 0, 0. Right. Let's see what happens here. K7 is wrong. Your output is 1, expected output is 4. Okay. Let me take help from the Guruji. Guruji is here, so you have to take help from them. You can't waste too much time, guys, right? उसका कुछ स्टेटस पता चल जाता तो, क्योंकि कई दिन हो गए उसका कोई स्टेटस अपडेट ही नहीं हुआ उसमें वेबसाइट पर। यस मैम। क्या बताना है मैम? एक सेकंड बस बताता हूँ। ऑर्डर आईडी है मैम SMS 2723 8 या 2723 8। यस मैम। यस मैम। ठीक है मैम। Okay, so what we can do? Give me recursive solution only first. Give me recursive solution first. Don't give me DP solution. I know how to convert that in DP. I think I know that. What is it? Okay, string ij DP solution, right, sir? Okay, okay, it's given person number. What? No, what? It's saying recursive given DP solutions. And we will try to return this. Okay. We will be behind it if you look at left and right. We will look here. No, no, no. Not. Okay, just a recursive solution for longest common substring. Yeah, so we have to have some count variable I j less than 0 return count. Okay, so we are coming from top down. Okay, right. Match path is as I can as j here. Now count match path is s1 I1 j minus 1 count plus 1. Okay, if it is not match, skip 1, skip 2, count minus 1. Okay, return max of match path, skip 1, skip 2. And it's looking good. Like let me code this, then we can found if there is another solution. Right, guys? So we are coming from this. We have some count variable also. Count. Alright. If I is less than 0, or you can say j is less than 0, so in this case we have to return the count variable, whatever count is. Alright, this will not work. If si is s1 I is s1 j, then return 1 plus, not 1 plus, I think s1 is si minus 1, we are going from top to down, j minus 1, comma, count plus 1, right. Okay, so wait a minute, just looking to confirm match path, how it's so into match path is count. Okay, right. So it's initializing with match path. Okay. Correct. Understand into match path. If you count, it will initialize with this. Turn match path. Like this. Okay. Else in the else case, what we will learn and skip 1 equal to s1 comma s2 comma I minus 1 comma j count skip 2 equal to s1 comma s2 comma I comma I minus 1 comma count, and we have to return max of match path, right? Max of 1 comma 2, like that. Right. And what we are doing is s1 dot size minus 1 comma s2 dot size minus 1 comma 0. I think it should work now. No, it's just not working. Your output is 5. Okay. Count plus 1 like that. I think. Wait a minute. What is the problem here? 0 minus 1 and minus 1. Alright. Like this. 0 0, what is 0? Count is always 0, okay. When it is not there, so we have to make the count 0 always. Okay, let's try to do this now. Let's try to submit it. Okay, it's very, it will give us okay, please press the that method will be we can do the recursive also, right? No, so we can use the DP method. So print DP. Alright, let's take this M and N. M is equal to S1 size, right? And then S2 size, right? And we are going to M vector of n, 0. Okay, or we can say -1 here, and we are passing DP here, right? And we can pass this DP to here also as a reference. Okay, DP of I comma j for this, right? And DP of I comma j like this. And if DP of I comma j is not equal to -1, return DP of I comma j, right? Alright, let's see what happens. Okay, like always we do this. Here and here. Alright. It's given wrong. Your output is 1, okay. I think we are okay, I think we should watch the lecture video of Striver for this. What's a good question here?
Hey everyone, welcome back to Take You Forward. So, in this video, we will be solving a bit different problem. And the problem is longest common substring. Substring, not subsequence. Okay, so what is actually a substring? In the previous video, we did learn about subsequence. The definition of subsequence was it can be something like A, J, P. That is a subsequence when you say it's not consecutive. A subsequence cannot be consecutive. But a substring, whenever I say substring, it has to be consecutive. Remember this, it has to be consecutive. That means either ABC, either BC, either CJK, either JKL. It has to be consecutive. It cannot have any characters left in between. So the definition of a substring is any portion, any consecutive portion of a string taken out is known as a substring. Now, given a string S1, given a string S2, the question is different. Longest common is same, but it is not subsequence. It is substring. Because if I was talking about longest common subsequence, you would have said A, C, J, K, A, C, J, K, and P as well. This is longest common subsequence of a length 5. But I'm talking about substring. So when I'm talking about substring, the longest common substring will be CJK and CJK. CJK. It can be the entire string as well. But over here we are seeing a length 3. Yes, over here we are seeing a length 3. So the question arises is, how do you solve this particular problem? Can you solve this using the previous formula? You can, but you have to do certain modifications. Yes, you can, but you have to do a certain modification. So let's actually look back at what did we do in LCS, the longest common subsequence. How did we solve this problem? Let's actually write the dp. So what did you write? You wrote dp of ij is equal to 1 plus dp of I minus 1 and j minus 1. That does make sense if they're matching. Yes, if they're matching, that is what you wrote. And if they're not matching, then you wrote something like dp of ij is equal to max of dp of I minus 1j and dp of I comma j minus 1. Now why does this not work? Why does this not matching not work? Let's analyze by taking a very shorter version of the example. So if I take ACD and C, let's say ACD and probably something as AXD. Okay. So in the longest common subsequence, what will happen is initially it will have DD common and it will end up doing 1 and then it will say let's shrink the string to AC and X. Now when it does not find C and X, what it says is let's omit one portion, then still compare A and AX. That is what it says. Let's omit one portion, let's compare A and AX and let's try to see if we can figure out something. Or it says, hey, let's omit X, let's compare AC and A. And over here it is like, okay, X, A. So let's omit A and try to compare, which gets it. If you're omitting A, you're getting AX. And other way it says, let's omit X and compare A and A. And eventually it compares A and A and gives a +1. This is the problem. And over here it is like, okay, X, A. So let's omit A and try to compare, which gets it. If you're omitting A, you're getting AX. And other way it says, let's omit X and compare A and A. And eventually it compares A and A and gives a +1. This is the problem. And why does this happen? Because of the omitting that you're doing. You're omitting this and you're still comparing with the entire thing. So you're doing a disruption. You are breaking the consecutive rule. Now, if there's a comparison between A and A and this D and D was compared, you know there is someone in between who was there. That's why you omitted this. You shrinked one portion of the string, not both the portions. Thereby, in the longest common subsequence, this works because you're allowed to have not consecutive. But over here, there is a line which says you have to have consecutive. Thereby, this line does not work because you cannot omit it. You need to be consecutive in nature. Okay, so how do you then solve this particular problem? So can we write a recursion? We can, but then we have to use one more third variable. Thereby there will be 3 states which I will not recommend. Thereby what we will do is we will try to write the tabulation format. But in order to write the tabulation format, you have to understand how does the longest common subsequence tabulation works. So please watch out 2 videos. One is the DP25 where I've taught the tabulation. The other is the DP26 where I've taught what does the tabulation, like what does the table exactly mean. I've taught that in DP26 where I've printed the LCs. So let's take an example of ABCD and ABZD. Okay, so over here the longest common subsequence is ABD and ABD, but the longest common substring is AB. Let's see how will you find this out. So as usual, we will be following one based indexing. So 0, 1, 2, 3, 4 and 0, 1, 2, 3, 4. So this is what we have written and this is our DP table. Okay, this is our DP table. So ABZD will be on the column and I will be over here, which is ABCD. Okay, so how do you usually fill up? You usually fill up on the column wise because this means this portion and this means this portion. So this is the DP table that we will fill up. So whenever I'm at here, let's see, what string do you have? A and A. Are they matching? Are they matching? So you can definitely put up a 1 over here. How did you put up a 1 over here? Remember this, if they are matching, what you did was you said 1 plus the previous guys. And the previous guys will be zeros. These are non-usable rows and columns, so zeros. Okay, perfect. Now you go over here and you say A and AB. Okay, so does this A match with this B? No. So thereby 0. Next you go to Z and you say A. Does this A match with Z? No. So a 0. Next you go to A and D. Does this match? No. So a 0. Perfect. Let's come to the next portion. You're over here and you're over here, which is A. A and B for here. So does this B match with this A? No. Ideally, since this is consecutive, you are not dependent on the previous guys. Since this is consecutive, you are not dependent on the previous guys. Remember this. Because you don't want any interruption. Because if they do not match, I don't want any interruptions to be carried forward. In the previous else longest common subsequence, you would have taken the maximum of this or this. Why? Because this A was matching over here. So you were like, okay, in this AB and this A, the longest common subsequence is of length 1 because that is the longest common. But in substring, you don't carry anything because we don't have a substring. Thereby a 0. So you'll put a 0. Remember this, you'll put a 0. Perfect. Next you'll come over here and there is B and there is B, right? But they're matching. So you're like, okay, they're matching. Let's see. In the previous guy, did they match? They did. There was a 1. If they matched and they had a length of 1, why can't I take that 1? 1 for himself and previous 1. So I'll be like, okay, I can put a 2. So whenever they're matching, I can actually take the previous guy because I don't need any break. There is no breaking. I can directly go to the previous guy and ask, did you guys match? And if you match, you must have some value. So why don't I take this? Perfect. Next, you come over here, this is Z, this is B. They're not matching. Just put a 0. Next, you come across here, B and D not matching. Just put a 0. Next, C and A not matching. Just put a 0. Next, C and B not matching. Put a 0. Next, C and Z not matching. Put a 0. Next, C and D not matching. Put a 0. No one is matching. Next, D and A not matching. D and B not matching. D and Z not matching. 0, 0, 0. D and D matching. So 1. Why 1? Because D and D was matching. So you went to the previous guy. C and Z. Since they did not match, they had a 0 value. Thereby, there's no 1. There's no 1 for the previous consecutive. You only had a 1. If this C, like over here we had a C. Then what would have happened? This C would have matched this C and would have said, okay, I'm having a match. So go to the previous and see. So they're saying they have a 2 match. So if they have a 2 match, you take this 2 and you say 2 plus 1 over here. Thereby you would have said 3. Then again you come over D and D, they're matching. So like, okay, they're matching, so 1. Go to the previous and see how many are they matching. They're saying we have a 3 match, 3 consecutive match. So take this 3 and a 4. So this becomes 4. So what I analyzed was, since it is for consecutive, thereby this guy can be said, we do not need to do any breakings. Like we did a breaking here and we moved to AX. We did a breaking here, we moved to ACX. There is no need to do any breaking, yes. Thereby you can directly put a 0. This is the slide change that you have to do in the previous code and you'll be able to code this. Okay, so coming back to the table. So let's actually come back to the original stuff, which was actually ABCD, and this was something like Z or something like this. Okay, so if I again redo the table, what is the value that it will have? It will have a value like 0 and it will have a 1. What is the longest common substring? Can I say the maximum value in the entire matrix? The maximum value in the entire DP, because this 2 signifies AB is equivalent to AB. Can I say the maximum value in the matrix is indeed the answer? I can, and that is the answer, the max value. So without waiting, let's get started with the code. So we are in the longest common substring. So what I'll do is I'll just copy paste the code for longest common subsequence. Let's copy paste that. And what we'll do is we'll just put a 0 over here. And this is str. Let's keep it s and t. Okay. What's the other thing? What is the answer? The answer is the maximum value. You can reiterate and find the maximum value. Or what you can do is, dp of I, j is just getting filled over here. This is the value whenever it is getting a value. Otherwise, it's 0 every time.
Okay, guys. That's enough. I think we can write code up by ourselves. So there is no... I think we need this dp of n plus 1 and and plus 1 here, and we initialize 0. So tabulation is master here, so let's go for that only. Okay. Before that, can we make this recursive solution work here? Okay. Let's see. Dp of I comma j is equal to. Okay, that will be very good. Alright. Okay, just to do stabilization, right, guys? And plus 1 comma 0, right? For and I equal to 1 is less than equal to m I plus 4 equal to 1 and j plus if s1 comma I is equal to for j, then value of I comma j is equal to dp of I minus 1 minus 1 plus 1, right? We find this here, okay, like minus 1 here, else dp of I comma j is equal to 1, no, 0, right? And we return this dp of m comma, right? Correct is dp. No. We have to traverse that also, right? No, 4 and 9 equal to 0. So we are going to do n I plus plus and equal to 0, j is less than equal to n plus plus if dp of I comma j is greater than maxi, right? Maxi is equal to dp of comma j. Like that. And to maxi is 0. Alright. Return maxi, right? I think it will work. Yeah. Correct. Alright, guys. It's working now. That's how it worked. I hope I was able to make that. make the solution absolute and vector of DP output comma vector of n comma n comma minus 1 like this, right? Okay, then this function that is there. What we are missing here? Okay, next of count what on this. What can we do? Wait. We have to restrict and right. If of S1 comma S2 comma 0 comma 0 comma event. Okay. No, like this. M minus 1 comma M minus 1 like this. Whatever. Oh, this. I don't know. Return. What's happening? And we can count also, right? 0. Now what? It's not your output is 1. Let me give this to our group. What are we filling behind? I think we are filling in where when this dp of I comma j action I think we are fooling the index here. Catching system, okay. And I have 3 variables. Okay, we have to count 3 variables, only to the state. Okay. So we have to okay, we have to give the count also. Y commercial is equal to if your character match, you will return the result and skip 1 and skip 2. Whatever string are like this and this Okay, 3D DP we require. We need to get some. No, but I want this 3D DP thing also to test, right? Let's try initialize 3D DP or what we can see. Trying to have a 3 here. So we have to initialize this DP. Something like this. Vector of vector and dp right and comma vector of int and comma vector of int and 1000 comma -1. Like this we are initializing, and we have to take this control C here, DP will passing only. Okay, control V with this right. Okay, DP also I comma J comma J comma count is not J comma count. Okay, J comma count. Alright, I do see what's happening now. Compilation error with root. Okay, here. What is it? Oh, 2D pizza. Please like it, okay. Let me see. Oh, it's working. It's working, right. Wrong answer for what? See here, let me check. See. Okay, so what was the explanation for 3D DP here? Okay, look at your function signature. 3 variables, okay. You imagine you have a branch instruction standing in block icon timeline. You have it where you arrive here having already verified it 5 block behind you, and count is equal to 5. You find 2 more matching blocks ahead. You write on the whole a block icon is meant to be 7. Okay. A clone of your arrived at the exact same block icon, but they just started a brand new count is equal to 0. They read the whole, see the 7 and report back. I found a block 7. The mathematical topology. The count profoundly alters the mathematical feature of the branch. It must be part of the DP cache. By omitting it, you forced timeline with different accounts to share the same memory. Overwriting corrupting each other. If you state as 3 changing variables, you must manually require a 3D array. Let's try by this. The character match, you will return the result and escape S1, S2. What if you string array S1 like this? A, B, X, Y, Z, A, B, underscore X, Y, Z. When you point at line on Z, they match. Your code look into the timeline, follows it backward, y and x, because it immediately returns it never supposed to close necessary look at the underscore and find the AB match. Because always simulates human symmetry is solved machine and okay. So if I and j are different for particular count, so we have to take account of that also. So that was the case, guys, and I have this solution. What is the error? It will some because it is giving wrong answer to me for some cases, so it has to give. Okay. You are on the edge of deep mastery, but you have left the early return trap in the core and you added the hardcore out of bound trap in the cache. For you are similar to always experimenting with real world logic. I am going to show you exactly how special code this okay, so db on db. When you are comparing two strings like this, the very end j is dead. The mirror is they match. Your code instantly logs into this timeline and say I found a match and return immediately. Do not look anywhere else. Yet step backward with this. Okay, they mismatch your current bridge collapse. So your code early return on first j. It never allowed the counters to flat part immediate because this belonged to the wrong j and code completely missed the true alignment. Okay. Maybe it's that you have the third option argument. And 0 and next edit for buses is in it. Long and okay. So out of bound also okay, right, like this. And return count. Randomize step diagonal backwards. Okay, notice there is no return. Okay, there is no return here. Okay, we don't have return. Alright. And also initialization will be max possible count. next one is okay. Alright. Like this, whatever. Like that, okay. We should not return here. Okay. Match path equal like this, and this is good. And match count is equal to min of n comma n, and here dp max count plus 1. Alright, I think it's super enough. Whatever. Oh, okay. We are again returning. And 27, what are 27? Okay. TLE is there. Okay, so this was this solution. This is a 3D, right? 3D solution. It will give TLE for the last 16 test cases. Okay, alright. After that, we have this. This is a 2D tabulation. Passage all tests. Right. Alright, so we have to make this one. Okay. Done. Longest common substring is done here, and I am going for eating lunch. I'll be back and